Hello everyone, good morning, good afternoon and good evening, and welcome to Las Vegas and to our first ARM Tech Talk live from CES. We're here. I'm your host Tobias McBride, and all week, together with some of our incredible ARM partners, I'm going to be bringing you a glimpse at some of the awesome ARM innovations at this show. This series really is the place for you to discover the latest trends, technologies, and best practices from the ARM ecosystem. So welcome and thank you so much for joining us. This is so exciting. It's my first time at CES, and if you can't tell how super excited I am for what we're coming up today, and to be honest, this whole week, because we are going to be live every single day, bringing you CES at home, at work, wherever you are around the world. Now, one of the things we're really excited about is to inspire you about what's coming from ARM's partners. And as such, we really want to invite you on a journey of discovery where when you look at all the amazing innovations unveiled at CES, you ask yourself, well, is this built on ARM? Because it probably is. So let's get right to it for today's ARM Tech Talk and talk all about automotive. I'm thrilled to be at our partners RTI's booth today and to be joined by Pedro Lopez, Automotive Director at RTI. Pedro, it's great you could join us. Thank you so much.
Thank you so much.
Thank you so much for joining. Now, this is, as I said, my first time at CES. Is it your first time at CES, or are you a bit more of a veteran?
I don't know if a veteran, because there are many folks here who have been here over decades. It's my fifth time, I believe, plus minus. And it's always great to be here.
It is, absolutely. So why don't you tell us a bit more? I'm sure many people on the call have heard about RTI, but why don't you tell us a bit more about who RTI are and how you really build on ARM technology out there?
So we are the software-defined vehicle supplier for one of the main middlewares that are today available in the market, which is DDS. But this is nothing new for us. We have been working on solving autonomous software-defined scenarios for a long time.
Yeah.
We did that for defense, avionics, and many other industries. And for the last 5 to 10 years, we have been focusing our efforts a lot in automotive. So we provide a solution framework that enables the OEMs to go from the low-level ECUs all the way to the cloud with a single middleware solution.
Awesome. Now, one of the key trends we're seeing a lot at this show, you see it on advertising, hoardings, and everywhere, and we see it in the industry as a whole, right, is this idea of a software-defined vehicle. It sounds really grand, and I'm sure loads of people watching actually don't even know what a software-defined vehicle is. They may be hearing this term for the first time. Do you mind explaining a bit more about, I'd love to get your take on what exactly is a software-defined vehicle?
So first of all, software-defined vehicle is the response of the industry to one of the main problems the OEMs are facing. And I think when you try to define something software-defined vehicle, you always need to think about the OEMs first.
Yeah.
So why the industry came with a solution called software-defined vehicle? The first thing is trying to standardize the hardware interfaces. And ARM is a key supplier in that concern, trying to standardize the way that you contact the hardware and then providing the value in the software levels. And the second point in that new architecture is defining the standard APIs. This is what we have here. You define standard API levels for the different use cases: zonal architecture, digital cockpit, high performance compute, telematic control unit.
Yeah.
And when you have all of that in mind, you provide the value at the OEM. So they don't need to think about how to architect their hardware system. They don't need to think about how to communicate with the level APIs.
Yeah.
You can focus on providing value at a higher level, standardizing the complete architecture for them.
That's awesome. That's really exciting. And, we were talking just before we got on this webinar about this software-defined vehicle, but also about the RTI Connect Drive offering, right? I'd love to talk with you to talk a bit more about how that really helps companies in the automotive sector transition to these software-defined vehicles. Do you want to talk a bit more about RTI Connect Drive?
Sure. So one of the key issues that the OEMs are facing when looking at the software-defined vehicle is the level of implication that they need to get at the software level for their particular vehicle. And this have a lot of troubles when you start thinking, when you need to maintain legacy systems working on AutoSAR Classic, AutoSAR Adaptive with 4, 5, 10 RTOS in the system from Winston to with different cores, ARM.
Yeah.
So you need to think about a way where you can focus on what you can bring value, which is application level coding. That's where RTI comes in place. We are able to abstract the hardware, the operating system, and focus on an application level with Connect Drive. And this is not easy because you need to provide components from AutoSAR Classic integrations to all the operating systems, all the way from M7s to A53s. So you need to have different footprints and being able to run it on the cloud. So Connect Drive is a solution in order to look at your system at an application level and taking care at the safety level, cybersecurity level, and footprint level. We take care of that and provide you a footprint with including products and tools to be able to communicate the complete system through DDS.
Awesome, awesome. Now, you pointed a bit about this wall behind us, right? Some really engaging demos and really engaging stuff here. If you're attending CES and you're coming to the booths, do check out RTI's booth and come and see this in person. It's awesome. Why don't we talk a bit more about this? And to do that, I'm going to switch cameras, so just give me a sec while I do so, and talk a bit more as you're showing us about some of the ARM chips in here, the ARM-based technology involved. So let me just switch cameras for just a second. I'm going to now pivot round and show this off.
So we are trying to show in a high level an architecture of a modern SDV. So if you think about a modern SDV, you will have from the low-level ECUs, including sensors, like you have your EPS, you have a couple of cameras, radar, LiDARs. So you have a sensor-level communication with the ECUs. You have a set of ECUs over there, which are NXP, so ARM-based, and another set of ECUs here, which are based on a different technology. And then you communicate through the zonal architecture. That's the first level for the software-defined vehicle. So you have there the NXP S32J, which is the main component that today is focusing on the software-defined vehicle architecture for zonal. The zonal part of it, we call it dynamic because you might have a single product line, for example, Volkswagen Group, but you would like to have from the low-level Golf all the way to the high-level Audis. So it's dynamic in the sense that you can create a different mounting option, and this architecture will understand by itself what if you have a high-level LiDAR with a high-precision GNSS, or you have a standard GNSS with a single camera. So that's the first component. Then everything is concentrated in the digital cockpit. The digital cockpit is able to display all the information on the vehicle, control position, speed, all the information that is going on with the vehicle. And you are not connected directly from this. You have the zonal architecture bringing the information to the digital cockpit. Another alternative is that that information from the sensors go to the high performance compute, which is a second system that we have here. This is for ADAS function. Here we have an NXP board, but as well we can do it through the Renesas board. Both of them having ARM-based technology. And we work at both levels. At the application level with the A family, with the R family, 53 and others. And we can work as well in the smaller footprint like the M family, M7 and other reports of that nature for more safety-related applications. And last but not least, we have the telematic control unit aspects of it, where you can go all the way to the cloud. We are collaborating with SOAFEE, cloud-based development, and then you can work on the cloud, which is implemented here or in the simulation part of it.
Awesome, thank you. Let's talk a bit more about SOAFEE in a sec. To do that, let's go back to our main camera, as it were, and do the old switch. There we go. So let's talk a bit more about SOAFEE. And actually, to be honest, there's a lot of collaborations. You can't quite see them at the bottom here. But there's a lot of consortia involved, which is just awesome. And actually, you can see some pin badges here. You've got quite a few. It's like kind of a Disney sort of pin badge display here. I'd love for you to talk a bit more about some of those alliances. Let's say SOAFEE is one, but also AVCC. How do you see the opportunities there for collaboration? What do you see the importance of those two key consortia here in automotive as being?
So I think the industry is looking at consortia much more seriously now, software consortia. I am a board member of another consortium called Covisa, but as well we are heavily participating in AUTOSAR, SOAFEE and AVCC. The case of SOAFEE is bringing each one of them is trying to solve a particular problem that the industry is facing. SOAFEE is a particularly important one because it's aiming to work on cloud-based development and continuous integration. CDCI, we have it as well over there. And it's really important that you are able to continuously develop in the cloud and flash it in these boards relatively easily. And that's a huge problem for the industry because being able to work in controllers that are positioned in the system with high levels of safety, like ACLD or ACLB, and being able to develop at the cloud and reuse that application code at the car, that's not a simple task. And that's the part where we are working with SOAFEE, trying to have the same architecture that you have in the cloud, with different operating systems or Red Hats or others, and bringing it in a target like NXP. That's a huge problem, and ARM is instrumental for that because they are able to be at both ends of the communication. And DDS as well, because we can run in a microservice in the cloud and then implement the same application here in the system. And this is the main focus that we have been working. We are really active in SOAFEE, in the working groups, and that's the main part that we have been doing. In AVCC, it's a slightly different problem, which is defining a standard architecture for ADAS systems, for autonomous systems. And there, RTI has been instrumental for writing a paper which describes a standard architecture that is able to implement a high-performance compute ADAS application in a standard way for the OEMs. We need to think always what's the problem that the OEM is having, and how do we help them solve it. And we believe that having a standard architectures that we can reduce the cost, make it more effective, and bring value at the OEM level, that's the way to go. And that's the part where RTI has been focused for AVCC.
That's awesome. Some really important consortiums and really important initiative you're doing. And actually, talking about SOAFEE, I understand you proposed SOAFEE blueprint as well. Now, the idea of a blueprint sounds really cool. I'm just going to say, someone who's outside of SOAFEE, before I heard a bit more about it, what's this blueprint? So I understand you proposed a blueprint. Do you want to talk a bit more about that, and how can people get involved in that?
So far, SOAFEE is proposing like open source blueprints, which are great because you can take them and move it to the next level. RTI is working to propose a commercial available blueprint, which it's easier to close the gap between an open source and a commercial version of it. So we are working on a proposal to bring a commercial blueprint to the industry so the OEMs can take the open source one, develop it in-house, whatever. That's totally fine, and it's accelerating a lot of the development. But if they want to go commercial, have an alternative, a commercial alternative. For those of them that might not have the time or the knowledge in order to take the open source and bring it to production, and they might be looking for a little bit more time-effective solution. That's the focus where we're going to push our efforts in 2024 at SOAFEE.
Absolutely. And talk about 2024 and SOAFEE, and indeed all about these industry alliances. There's been quite a big announcement today about the STD Alliance, right? This kind of collaboration of collaborations between SOAFEE, Eclipse STV, Cavesa, and AutoSAR. I think I've got all four of those, right? It's a really exciting announcement. I understand you've been involved with it as well. Do you want to talk a bit more about that?
So this is something, today we are seeing the press release, but the work by the four organizations is coming from at least a year of work. We all met in Cologne in the facilities of four in July. There was a certain announcements as well as in ELIF, in the conference similar to CES. And afterwards, there was a definition of two working groups, like more marketing working group and the strategic working group where I am part of, in addition of being board member at Covisa. And what was really incredible is how these four organizations that from outside might look, they're looking at completely different problems. We all sit together in really looking for what's the problem that the OEMs are having and trying to solve it. And we are coming now with the first step of many, hopefully, on providing a consolidated view on SDV, which was, even though from outside might think simple, right? It's not simple at all.
Not at all, no.
Sitting AutoSAR with their low-level kind of application, AutoSAR class and adapted, SOAFEE, which is much more futuristic, looking at the cloud-based development, Covisa, which is coming from Geneva times, digital cluster, and looking more for a vehicle data model, and Eclipse, which is more an open source, and making them agree on a definition of SDV. That's not a simple task. We managed to do that. It's the first step, and we look forward to bringing more value to the industry together.
Absolutely. It's a really exciting opportunity ahead. So thank you, Pedro, and thank you, RTI, for hosting us today. Do you have any final words before we do wrap up for our audience today?
I think that what is crazy about the last 12 months, it might be like 12 months, not a long time, is that from last year to this year, where SDV was like the catchy word, this year is much more defined. Activities such as the SDV Alliance helps for that. And we believe that we are really now in the last steps of the zonal architecture and the first step of the software-defined vehicle. So those of you who are in CES, make sure that you get everything that is coming out of the software-defined vehicle suppliers, and we look forward to receiving you here in our booth.
Absolutely. And what's the booth number?
What's the booth number?
5276.
5276. 5276.
I was looking for it, and I don't see it anymore.
No one told us that. It's all right. It's absolutely fine. In the West Hall, 5276, in the LVCC. So come and check that out. And also, do come and check out all the ARM partners at CES. I believe there's a link I pasted in the chat for you now. So do go and check that out. It's really exciting. Loads of ARM partners are listed there on arm.com, so you can go and find out where they are, the ARM innovations they're showing off. So do check that out as well. So that concludes our first ARM Tech Talk live at CES. But fear not, we're going to be back today live at 4 p.m. to hear from Lenovo. and they've got some really exciting AI accelerated innovation based on ARM. And as I said, we're here every day, 10 o'clock, and at Pacific time, and 4 or 5 p.m. Pacific time, with a live stream from a different ARM partner at CES, discovering all the exciting new innovations based on ARM. Thank you again, Pedro. Awesome ARM Tech Talk. Thank you, everyone. We'll see you at 4 o'clock to hear from Lenovo. See you then.